Hello, everyone, and welcome to week 4 of CME 610 Data Science in Education. This week, we are focusing on statistical reasoning, distribution, and educational decision making. Up to this point in the course, we've examined educational data sets, metadata, data quality, and the ethical dimensions of data system. And this week, we're going to begin moving more deeply into statistical interpretation and quantitative reasoning. One of the major goals of this week is to help us think critically about how statistical tools are used to describe, compare, and interpret educational experiences and opportunities. We know that statistics are incredibly powerful because they help researchers identify patterns, summarize information, and make decisions. However, statistical information can also be misunderstood, oversimplified, or misused. So, throughout this week, we're going to examine how measures such as averages, variability, distributions, and quantitative comparisons shape educational narratives, policy decisions, and public understanding. One idea that I want to emphasize this week is the difference between statistical reasoning and simply performing calculations. Statistical reasoning involves interpreting data in context, evaluating evidence, recognizing variability, and making thoughtful claims. In many educational settings, students learn formulas procedurally without fully understanding what statistical measures actually represent. For example, calculating an average is not the same thing as understanding what the average tells us about a population or an educational experience. Statistical reasoning asks questions like what patterns are present, how much variability exists, what conclusions are justified, what limitations should be acknowledged, and what contextual factors matter. This week encourages us to move beyond procedural calculation and toward thoughtful interpretation. This week, you will work with measures of center and variability, including concepts like mean, median, range, and standard deviation. These statistical tools help summarize data and identify patterns. However, statistical summaries can sometimes hide really important realities. For example, two schools may have similar average mathematics scores while having dramatically different distributions of opportunity, resources, or student experiences. Similarly, averages can sometimes mask inequities within populations. This is why it's important to examine distributions and variability rather than rely only on single summary statistics. Educational researchers must think carefully about what statistical measures reveal and what they may obscure. Distributions help us understand how data are spread across a population. In educational research, distributions can reveal important information about access, achievement, opportunity, participation, and inequities. For example, distributions can help researchers examine patterns that are related to advanced coursework access, school funding, teacher distribution, disciplinary practices, or achievement gaps. One important idea this week is that distributions are not just mathematical objects, they represent lived educational experiences. So when we analyze distributions, we're often examining how opportunities and resources are distributed across communities and learners. This week's readings also encourage us to think critically about what we've been calling gaps in education. Educational conversations often focus heavily on achievement gaps, which emphasize differences in outcomes between groups of students. However, many scholars argue that focusing only on achievement gaps can unintentionally reinforce deficit perspectives. Opportunity gaps focus and shift the focus towards systemic inequities, such as access, resources, instruction, technology, experienced teachers, and learning opportunities. So rather than asking, what do students lack? We begin asking what opportunities have been unevenly distributed. That's a very different and much more equity centered question. Statistics shape public narratives about schools, students, and communities. Educational rankings, accountability systems, standardized testing reports, and media headlines often rely heavily on statistical comparisons. But statistics can be communicated responsibly or irresponsibly. For example, graph scales may exaggerate differences. Important contextual information may be omitted. Small sample sizes may be generalized inappropriately. Correlation may be mistaken for causation. And as educational researchers and mathematics educators, we have a responsibility to critically evaluate statistical claims before accepting them at face value. This week encourages you to think carefully about how quantitative information shapes public understanding and educational policy. On this week's foundational readings, they help us to think about the relationship between mathematics, statistics, and data science. So, what you'll find is that the authors are going to argue that mathematics and statistics provide the conceptual foundation for data science. That's important because sometimes data science conversations become overly focused on tools, software, or computational systems while overlooking conceptual understanding. Statistical reasoning requires more than generating outputs. It requires interpretation, that contextual understanding, and critical thinking. As mathematics educators, we play an important role in helping students to develop all of those capacities and capabilities. This week, we'll also introduce the idea that quantitative information must be communicated visually and responsibly. Visualizations are powerful because they help people quickly identify patterns and relationships. However, visualizations can also mislead. So, choices related to graph scales, color, labels, categories, and representation all influence interpretation. This week's visualization exercises are designed to help you think carefully about how quantitative information is represented and communicated. We're beginning to build toward later conversations in the course about data storytelling and critical visualization. This week, you will complete the Quant Hub module focused on central tendency and variability, the symmetry audit activity, the data visualization exercise, and data reflection memo number 3. As you complete these assignments, I encourage you to focus not only on performing the calculations, but also interpreting what the data suggests about educational experiences and opportunities. So ask yourself, what patterns are visible? What inequities may be hidden? What assumptions are shaping interpretation? What additional information would strengthen understanding? These questions are central to responsible statistical reasoning. As we close this week, I want you to continue thinking about several important questions. How do statistical summaries shape educational narratives? What happens when averages hide variability and inequity? How can statistical reasoning support more equitable educational decision making? And how can mathematics education help students critically interpret quantitative claims in civic and public contexts? These ideas will continue guiding our work as we move into research design, exploratory analysis, ethics, and data visualization later in the semester. I'm looking forward to engaging with your ideas this week, and I hope you enjoy exploring the relationships between statistics, interpretation, and educational equity.